Hello, hello everybody. So this is a screencast for augmented reality 3D Pong. This is another screencast for learning 3.js blog. This one gonna be a bit different. So I'm gonna try to do live coding of this program. What is augmented reality 3D Pong? This is a bit of augmented reality plus a bit of WebGL. All that to add a spice, let's say, of a game classic, Pong, on some live coding. All that being augmented Pong in WebGL. A lot of fun with technology. Let's start. So, first let me show what we're gonna try to code together. So, you see here, this is me through the webcam. I got two flashy balls just there, one green, one orange. When I move the orange ball, you see the racket on the right moving. You see up, down, up, down. On the right, on the left, you can see obviously the other racket moving. Two colors, one for each racket. On this way, we play Pong. But I play Pong in reality. I don't touch my computer to interact with it. So we are doing what we call augmented reality. Alright. And we play Pong. And we're gonna do that in 100 line, no more than this. Let's do that in live coding as much as we can. Okay, so this was augmented reality 3D Pong. WebGL on the screen, as you can see in the middle, with tQuery, augmented gesture here, on some menu here in order to tune your image recognition, image processing. So what we're gonna do is quite basic. It's quite simple more. Is first we are trying to do live coding of this game. It's gonna be split in three parts. First, the initialization with tQuery for 3D and augmented gesture for augmented reality. Then we're gonna code the players, then we're gonna code the balls. But first, let's start by the libraries. Step 1 is to initialize library. So, why do we use library first? That's a good question. We use that mainly for code size. Library help us produce very short code. Let's not forget that we got only 100 lines for our game. So for this, we do 100 lines. It's pretty efficient, right? We got WebGL on the screen. We got some tuning with some menu here. And we got some image recognition, gesture recognition based on virtual in 100 lines. It's pretty short. We do that thanks to the library. Which library do we use? Mainly two. One is augmented gesture, the other one is tQuery. Augmented gesture is done for the augmented gesture. So let me explain what is it. It is this small window, the two pointer moving the rackets, all the image processing beyond that. This is the augmented gesture. After that, you got tQuery in order to display the WebGL. Alright, all that under MIT license, so pretty cool. Now, let's install augmented gesture. We take this line. Here we got a very basic HTML5 page. We include our augmented gesture bundle. What is augmented gesture bundle? So this is augmented gesture, the library, plus a bunch of useful JavaScript files, such as the dependency, the image processing.js, these kind of things. Now that we have included augmented gesture, we're gonna initialize it. So we do something like this, probably like that, alright. And let's launch this. We got that, and we got no pointer initialized. We got no pointer initialized. As you can see here, it's only general. There is no pointer initialized like when I go into the result. You got pointer right and pointer left because I got my two balls or they're already configured. So you you got two pointers into augmented gesture. Currently we have only initialized the augmented gesture. Let me explain what we have here. Quite simple. So var augmented gesture is equal to new augmented gesture. So this is an instance of the augmented gesture. Enable .gui. .gui, this is those kind of menu here that you can play with in order to tune augmented gesture interactively. Start is quite simple. That means that you're gonna start monitoring the webcam for movement of pointers. And the DOM element thumbnail is to initialize this output here. This way you know what augmented gesture is seeing, and thus this is pretty cool. You can see what you are doing. Alright, so once you initialize your object, set you enable .gui for interactive tuning, then .start to start the monitoring, and then you add the thumbnail view, the webcam as a thumbnail. So what is augmented gesture? This is basically people moving color balls in front of the webcam, nothing more. And here I move color balls, but you can move post-it or stuff like that. The marker just have to be in a flashy color, something quite recognizable from your image. So this is this. The computer look at those color balls, analyze what you see, and find out the position of the cross here. That gives you a pointer. Pretty simple stuff. It is quite nice because this is much cheaper to play with than the Wii or the X360. And you can do that easily. I wanted to experiment with augmented gesture for games, so I did this. Alright, this is augmented gesture, so library is augmented gesture.js. You can find that on the web here. And you got a GitHub. Go GitHub, go. Somewhere, alright, you got a GitHub with all the source in there. It interprets the gesture in front of the webcam with the webcam. Some image processing is done with a small library that I did. And you read the webcam with WebRTC and get user media. This is all that for augmented gesture. But look, all that is done in very little code. Doesn't work? Show me my computer. Alright. Currently, you got that. You got the menu to tune, the webcam being read, all that in this single line. I mean, this is super short. So you do that. You created the augmented gesture. Now, what's next? You have to install tQuery for WebGL. So let's do that. We take the tQuery bundle and we include that here. We got the tQuery bundle, obviously contain tQuery plus three.js. And so what is tQuery? Do I have a slide on this? Yes. So first you install the tQuery, then you're gonna produce a 3D, tQuery is a 3D library mimicking jQuery API on top of three.js. It tries to ally the three.js power on the jQuery API flexibility. From very, very far, people knowing jQuery can learn tQuery in no time and thus access WebGL easily. This is the goal of this library. Now, obviously, you got all that on GitHub, you got quite a site associated with it, blah, 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 many stuff. And you got this very basic page here. So let's try to do that. This is a boilerplate of tQuery, only 6 lines, by the way. Always trying to have shortcut. So here we initialize the world. Init world of tQuery. Then we go test our code. Sorry, it should appear. Apparently not. Because we don't have the tQuery bundle. We haven't taken the tQuery bundle which is needed to do it. So let me go fetch tQuery bundle. We're gonna go here, take, so cd example, cd screencast, this is our code here, the index HTML we got here, so we take the tQuery bundle, we copy that in the proper directory, we'll come back, and we reload. As you reload, you got the tQuery boilerplate in the background, the tQuery boilerplate that we just added here, with an object. So let me detail what we got here. Do I have a slide on this? Yeah, well, almost. So here I got a tQuery, I create a world, I create the boilerplate on top of it, I add the boilerplate on top of it, and then I start the world. So the world is a rendering loop, a camera, a WebGL renderer, as if not especially WebGL, and that's basically it. So after that we got our 3D world. Once we have done this very short line, we got a 3D world, and we are able to display WebGL stuff. And the toys that you see in the middle is exactly that, WebGL stuff. What is this toys? That is the line just after. tQuery create toys add to world. Not too hard, and we got this object just there. This is the toys that you see here. Pretty simple, but not interesting in our case, so we're gonna remove it. So we remove this one. Additionally, we're gonna remove the camera control. You see the camera control is the one doing the when I move the mouse like that, the camera is moving around the torus, so you see the torus moving. We don't need that for Pong, so we're gonna remove it. And remove it with something simple, which is these two lines. So I do that, I remove those two lines, and I get this. So you have no more object and no more camera control. But that's where we want to go. Alright, so this was how to install the library. Now we will see how to do the players. So we are coding the players. So we go here, we're gonna start real simple with only two basic variables. We go in our source, some constant for the players. We put that here, player ID, we're gonna play with the ID right, and after that a little variable players to store it. Now we create the 3D object for our players. And we do that obviously with tQuery, right? Okay, sorry, some indentation fixing. Here you got create tQuery object 3D for a racket. We're gonna create that. We use this simple function here, tQuery create cube, because in fact a racket is a cube, right? That's more rectangle, obviously, but that's a cube in a way. So after we do create cube, we add that to the world, and we set the size, because our cube, obviously, the cube on to the racket, you more rectangle. The line after that is quite simple. You translate just a bit to the right, and it's kind of cool. And after that, you store your 3D object in your player object. Let's see what's happening. Not much. I have to save the file, okay. Alright, so it happened, excellent, we are here in the code. Let me move, yeah, because I don't have anything right now, but I got my racket just here, nothing is moving, but at least we have the 3D. That is how small is this, right? This create a cube in 3D. Like what, 60 characters? Okay, so we have our tQuery object 3D. Now we're gonna do the augmented gesture for this racket. So first we create the object itself. I mean, for our pointer. So we do that this way. We add a pointer for this player. Here we just instantiate the option for our pointer. The option are all the way you tune it, right? All those stuff that you see here. And after that you add a pointer. So if I reload, you see there's many options here, and this is what allows you to have a perfect tuning of your pointer. All that will improve. So now we have our pointer just here. It has been implemented, it's working. Now we need to tune the color of it. In order to distinguish the pointer on the screen, I need some specific color for to know. And look, I move my orange ball, and there is a pointer following. How great is this? Alright, so once we have created the object itself, tuned the color, we're going to bind them together. Here I mean the tQuery object and the augmented gesture. So first we initialize some stuff relative to the racket size. Let's say we put that here. So what are those variables? Racket width, so the width of the racket. Racket 8 for the H for the 8 of the racket. Notice that those sides here are the same as those sides here. Here you got what? You got a racket range 2. It's a range of for vertical range for the racket. Now we have initialized some global. We need to move the racket according to the pointer coordinate. Surprisingly, these 3 lines are enough. So what do we get? We get, let me grow the font. You bind the gesture, mouse move, and update object 3D position with it. That's quite simple. You do a gesture that you have instantiated a bit above, something like here. You got your augmented gesture. Here you have created a pointer with player ID. So you bind mouse move dot right, because that's your player ID. You bind this event and you call a function just below. This function got an object here, and this is quite simple. You got event.y, which is the position in y. So this line will update the position of the object 3D for y with this coordinate. That's simple. No more, no less. And look, it doesn't work. Why it doesn't work? Because I have to save the file. Okay, I know it worked. Okay, so we bound them together, and it worked, and that's pretty nice. Now, what do we have to do? We have to make that generic for 2 players. Currently it works well, up, down. We got the 3D moving at the same time as we got the augmented gesture, so all is working okay. But we got only 1 player. We want 2 to play Pong. So let's do that. First we initialize the variable which is going to store our players. We put that here. That we put that below like that. Then we loop over the structure to loop for each player. We have to create 2 players. So let's do this loop. We loop here. We loop for each player. So I'm gonna put a little comment here. And after that, I go here, I go here, and I loop over each player. Supposed to work. Alright, I'm not sure it's gonna do much. Ah, yeah, it's not gonna do much because you have noticed that I create twice the same player. The only difference between the two is the name, pointer right and pointer left. Oh, you can see I create 2 here. Now we're gonna try to have first distinguishable rackets. Right? The first step is to move the racket to the right or the left depending on the player ID. And we do that with this simple line. Hop. So if player ID is equal to right, then my plus 1 or minus 1, and multiply this value by plus 1 and minus 1, so that's the right or the left. See, first we got two rackets, both controlled by the same color. We got two pointers but bound to the same color, so they move at the same time. It's not too cool. Let's try with this call, something like this. Okay. Okay. Messing up. Okay. So here I'm just putting a if in order to have two colors for our two pointers. If the player ID is right, we set up some special colors here. Player ID right, special color here for the player right. If it's not right, so it is left, the color for the left. I save the file, I go here, and I move. Pretty cool. Alright, so we got the players, and they are both moving. See, I move the green ball, the left is moving. I move the right ball, the right is moving. Pretty nice. See? So you have to put that in the proper hand. Oh, it's pretty cool. Alright, now we're gonna cut the ball because all that is cool, but we got only two rackets moving. We need a ball in between. Boom. Okay, so we have coded the players now, but we need the ball. As you can see, we got the two rackets, left, right. We got two rackets working, everything is okay. But we missed something, we missed the ball. So first, the 3D, initialization of some constant, well, some basic stuff in order to keep a code rather nice. Up, constant for the ball. So that's the radius of the ball. We want a ball of this radius. Here we add the 3D, so it's surprisingly easy, right? Let's not forget here we are doing WebGL. So tQuery creates sphere at two world. So suddenly we got a sphere in the world. We scaled that by ball radius. So now our ball is 1/5 of radius. Not too complex. And this was creating a ball in WebGL. tQuery. Alright, so make tQuery object move. First we have to initialize the ball velocity, right? Why we need to initialize the ball velocity? Because if you move, you need to move in a given direction, which is called velocity. That's a physical term. Speed. So first we pick an angle at random between 0 and 2p. For x we do mat cos multiplied by a constant, which is the speed, and velocity, mat sin the angle multiplied by the speed. So we got the ball velocity, not too complex. Now that we have the ball velocity, we'd have to use it, right? So we have to loop to update the position with the velocity. This is an important part here. You got an animation with tQuery. So we got the world, tQuery world, we access the rendering loop. We hook a function to this. Here we capture the position of the ball 3D being a 3D object from tQuery. We get a position and we update the x and the y with the ball velocity x and y. See how WebGL can be complex sometimes. Alright, so with this, I create this, I reload, and it doesn't move at all. Great. Why doesn't it move? Position, no, because I have to save the file again. So it's moving. Every time I load, you can see the mouse. So now we need something. We need the field collision detection. what that's supposed to mean is when the ball go here, there is a limit, or it's gonna bounce on the limit detection, right? So first, we got a field, we have some constant for the field. We put a constant for the field. Very simple. 3 units of width on height. 1.8. Pick the one you like, guys. Now we have to bounce on borders. What does that mean? That means that if the position of the ball is less than the average, than the half of the field, then you change the velocity in x. Same thing for y on 8. Seems simple. That doesn't seem to. That seems more scarier than it is. Believe me. That's really when you reach the border of the field. This is this if. Then you invert the speed, and you do that in for border of the field. That simple. Now we need to ensure that we are inside the boundary. So how do we do that? We do that with this piece of code, which is very similar to the previous one. That means that if position the x is less than this value, then position the x is set to this value. That's clamping. Okay, so you got the field now. So we're gonna have both bounce in this ball. See, it's bouncing. And the rate is not too good because I need to kill some browser. Alright, the rate is bouncing now. We're gonna try to go on at this speed, do you think? Is it fixed? Partly not. Okay. So, now we need to player collision detection. What that's supposed to mean is when I move like that, the rackets, the ball need to collide on my racket. Currently, you see it's going through. Let me show you. Going through. Going through. Alright, so it's going through, not too good. So we need to do something like this. Here, we kill that. We come back. So we got the player detection. Now we need to loop over each player because there is 2 rackets, so we need to detect the collision with each of them, each of the players. So we got right, left for each player ID. So you got player ID being equal to right or left. Here we take the tQuery object ID for these players. So this is these variables. Here we take the racket X and racket Y. So that's the position of the racket for this player. We have that. Now we want to know if there is collision. So once again, this pack of lines, which are not too digest, but they are really much simpler than you can think of. Honestly, that's really not complex. So let me put some indentation to show how similar all this is. So you hit on the left of the racket if this condition is true. You may hit the right of the racket if this condition is true. You may hit the top of the racket if this condition is true, blah blah blah. You may hit if this condition is true. So you got those 4 Boolean variables. And you find out that if you do something like this, if all conditions are true, then you actually hit the racket. That's simple. So if I go here, there is collision. That's simple. So the reaction to the collision is this. Let me explain this code. First, because we touch the racket, we have to inverse the velocity in x. This way it's going this way, up, inverse, so the velocity is different. Poof, poof, we put in x. After that, what is this? Ah, yeah, that's ensuring the racket position once again. You bounce and you put the ball exactly at the proper place. Okay, so there is no double bounce. That's the same thing as here. You guarantee boundary. Here, same thing, guarantee boundary. So you can notice that both are very similar. Why are they similar? It's very simple, because both are collision. So, the very last step, enjoy! You're fucking done. Not fucking. You are done, and that's pretty cool. The video is coming. Alright. And you move. And it's all cool. Yeah, so let's take collision. Up, collision. 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 Hop, back collision. I remove. You see, it's go backward. So, you are done. What have you done? You have augmented gesture here inside the thumbnail with the webcam on WebRTC. Here, .gui in order to do all the options. tQuery on three.js for the WebGL below. And all that, look at this, we got 100 line. We got 100 line for that. That's extremely short. So I'm quite happy to have done this screencast, and as I wanted to do some experiment on how to use this as this augmented gesture things with gaming, so this is the first try. I hope you enjoyed it as well. See ya, guys.